Beneath the surface of the ocean, between 200 meters and 1,000 meters, lies the twilight zone, or the mesopelagic zone. Despite the coldness and darkness of the twilight zone, many different creatures thrive in this environment, like the bioluminescent cyclothone. While the epipelagic surface is dominated by phytoplankton, not enough sunlight penetrates into the mesopelagic zone to fuel photosynthesis. There's also not a lot of nutrients or food available in deeper zones, and many marine creatures overcome this predicament by performing diel vertical migration. Diel vertical migration is when many marine creatures, mainly zooplankton, migrate up to the surface as the sun is setting to feast on the yummy phytoplankton. The darkness of the night protects them from light-dependent predators, so they can eat in peace without having to worry about being eaten. Once the sun begins to rise, they migrate back down into the mesopelagic zone where there's fewer predators. This process happens daily and creates an interesting phenomenon called the deep scattering layer. During World War II, warships would emit acoustic signals to find enemy ships, but they kept getting back signals that looked like the ocean bottom. Even stranger was that these false bottoms kept shifting. Eventually, they figured out that these layers were migrating zooplankton and mesopelagic fish. The swim bladders of the mesopelagic fish would reflect the acoustic signals, forming a clear layer known as the deep scattering layer. Now back to the zooplankton. What are some examples of zooplankton anyway? Well, there are copepods, tunicates, krills, ostracods, salps, and fish larvae. Diel vertical migration is mainly performed by zooplankton. However, other marine creatures also perform this migration. Many mesopelagic fish migrate, though their migration is slightly less about avoiding predation and more about getting food. The most commonly migrating group of fishes are the lanternfishes, or the Myctophidae group. These fishes migrate with the help of a gas-filled swim bladder, and some alternate between vertical swimming and horizontal gliding as they travel up the water column. Some even have heat shock enzymes to help them as they travel from cold, less oxygenated waters to warmer oxygenated waters. How far they migrate can vary. Some migrate higher up in the epipelagic layer, and different species have varying migration lengths. Not every mesopelagic fish migrates. Some stay in the twilight zone, like the previously mentioned cyclothone. In one study, there were different migration patterns observed for lanternfishes. For one group of lanternfishes, at daytime they would stay at a depth of 500 to 1,000 meters below, and at nighttime they would ascend and stay up at a depth of 0 to 100 meters. The second group would stay in waters up to 200 to 500 meters deep during daytime, and at night they would ascend to a depth of 0 to 100 meters as well. For lanternfishes, migration is important and is done to find food, to reproduce, and to escape the light-dependent predators. So how do they know when to ascend and when to descend? Some scientists claim that some zooplankton have their own form of circadian rhythm, and that changes in irradiance can switch on certain genes that serve as their internal clock. Of course, these genes aren't the only cause of DMV, as other external factors like food, predation, oxygen levels, and temperature can influence their migration behavior. Changes in seasons and ocean turbidity can alter the light intensity and therefore alter migration depths. Vertical migration behavior can vary depending on body size as well. Larger, mature zooplankton tend to migrate greater distances and are more likely to perform the classic diel vertical migration compared to smaller, immature zooplankton, since a large size equals more visibility to predators. These large zooplankton must travel greater distances to reduce visibility as much as possible. Many predators eventually learn to take advantage of this migration, which can lead to a reverse diel vertical migration. For example, in one study conducted in Dabaab Bay, Washington, pseudocolanus copepods were found to ascend to the surface at daytime and descend at nighttime, which is when its natural predators would usually ascend. Its predators are the Sagitta elegans, an arrowworm, and Euchida elongata, a larger copepod. The main surface planktivorous predators preferred the larger zooplankton and had a low preference towards the smaller pseudocolanus copepod. Anyway, creatures such as ocean sunfishes, baleen whales, and sharks often take advantage of this migration as well.